We're going to be solving the following problem. So if a NMOS FET with WL has the following value, we have VGS, VDS, we're asked what's the drain current in microamps. This is actually a really good problem to solve for, and this is how we're going to do it. We use the notes in the description below the like button to solve for it. Now there's a couple different equations that we're going to come across. We can come across this one that I have listed right here. However, we're not going to use it, so I'll actually get rid of it. And instead, we are going to focus on this one right here. Now with this one, if we look at the following values, the first we need to decide is if it's in triode or if it's in saturation. So for this, we are going to have our VDS, and it's in saturation if our VDS is greater than or equal to our VGS plus or minus our VTN. And so with this, we can figure out that this is greater than that, so it is in saturation. Now for this problem, you can see over here I started looking at the COX, but we don't need to do that because we are given this K prime N. This K prime N can substitute for this right here. Like, we don't need to solve for this because we have this. So we can just substitute that in, and that's what I've done right here, this 100. Now you can notice I didn't include the units here. That's because if we have it in microamps like this, and our answer wants it in microamps, well, we're just going to get it in microamps like this. You can write the units down. It is good practice. So this is microamps over voltage squared. We're just going to follow the equation, really just plugging in values. This is going to be in voltage. This is in voltage. So we have our voltage here, and then we would have a voltage here. The voltages would just like divide out, and they would get rid of each other. So that's how we work with that. This is the voltage squared. And then we have our 1 plus lambda. We have our VDS in here as well. So that's the 1.33. So really this is pretty simple. If we have the equation and we know it's in saturation, we're just plugging everything in. And from this, we are going to get 1224.48 for this particular problem. And this is in microamps.